Hi guys. Today we're going to go over question 7 from the 2015 exam, paper 1. Alright, so we have a plane flying into land. A plane is flying horizontally at P at a height of 150 meters above level ground. Flying horizontally. When it begins its descent, P is 5 kilometers horizontally from the point of touchdown, and the plane lands horizontally at O. Taking O as the origin, okay, and fx describing the path of the plane with fx equal to this polynomial. Alright, so what do we have from here? Well, P, our point P is, what are the coordinates of P? Alright, well it's 5 kilometers to the left of the origin, so the x-coordinate is minus 5, and it's 150 meters above the ground, and we're measuring in kilometers, so the y-coordinate is 0.15. Alright, our function then is f of x equals 0.0024x cubed plus 0.018 x squared plus cx plus d. So presumably the questions will be asking us to find c and d. Alright, so now if we move on to the first part of this question, we have to show that d equals 0. Okay. Alright, so we have our function f of x, let's just write down our function, equals 0.0024 x cubed plus 0.018 x squared plus cx plus d. Alright, so we want to isolate the d term, and an easy way to isolate the constant in a polynomial is to let x equal 0. Alright, so if we let x equal 0, then we get f of 0 is 0 plus 0 plus 0 plus d. Okay, what is f of 0? Well, f of 0 would be the y-coordinate here. And the y-coordinate here is just 0 because that's where it touches down. So 0 equals d. Alright, so it is just as simple as that. Very easy, very nice start to the question. Now on to part 2. Using the fact that P is the point minus 5.15 or otherwise, show that C equals 0. Alright, show that C equals 0. Okay, well we already kind of knew that that's what P was. So again, let's just write down our function 0.0024 x cubed plus 0.018 x squared plus cx. Alright, so are there any points that we know the x-coordinate and the y-coordinate? Are there any points along the journey? Well, we know the origin, but it doesn't really help. And what we also know is here, and that's kind of the hint, using the fact that P is that point. Alright, so when x is minus 5, so x is minus 5, the function is equal to 0.15. So f of x, because remember the graph is x f of x. The function, the graph is x f of x. Okay, so if we put in minus 5, 0.018 minus 5 squared plus c by minus 5. Well, this should equal 0.15. And so we'll get on this side, so we're going to calculate this, and then bring them over here. And this will give us minus 5c is equal to 0.15 minus 0.0024 by minus 5 cubed minus 0.018 by minus 5 squared. Minus 5 squared. And this just equals 0. So c equals 0. Alright, so it is as very nice start to the question. Now, alright, so on to part B of this question. Find the value of f prime of x, the derivative of f of x when x is minus 4. Okay, so straight away, derivative. We want the derivative, so that's going to be our focus. Well, what is our function? Let's just write down our function. 0.0024 x cubed plus 0.018 x squared, and that's it, because we showed that c is 0. Alright, so well, we know from our rules of calculus, and it'll say it in the log tables, that the derivative of x to the n, for some value of n, is n, bring down the power, and then reduce the power by 1. Nx to the n minus 1. Alright, so what will that look like in our case? Well, we'll have 0.024, that'll stay the same, and then we'll get 3x squared. And then similarly, we'll get 0.18, and then we'll get 2x in here. So that will just give us 0.0072 x squared plus 0.036 x. And that's our derivative. So now we have to find the value when x is minus 4. Okay, so let's just sub in minus 4. So f prime of minus 4 will be 0.0072 by minus 4 squared plus 0.036 by minus 4. And that gives us 0.0072 by minus 4 squared plus 0.036 by minus 4, which is minus 0.0288. Okay, so that is our answer. Now use your answer to part B to find the angle at which the plane is descending when it is 4 kilometers from touchdown. Okay, so use your answer to part B. Alright, so we know we're going to be using this somewhere. To find the angle at which the plane is descending when 4 kilometers from touchdown. Give your answer correct to the nearest degree. Okay, well, what the hell is this? How the hell could we find out what this is? Alright, so let's look at, so what would this, let's try and visualize this. So they gave us a nice little graph. What could this be? Alright, so the angle would be like this. 1 minute. It might be something like this. Well, actually, interestingly enough, it looks like it actually hits the origin or close to it. So the angle would be, let's change the color, some purple. So it would be this angle here. So we want to find out what this angle, let's say theta. What is this angle theta? At this point here. Well, if we find out what we have, we know that the derivative is the slope at that point. It's the slope. So the slope, well, what's our formula for the slope? So we know that the slope at 4 kilometers from touchdown, the slope is the rise over the run. So in this case, the rise would be, let's go from here. The rise would be, let's say, this much, and the run would be this much. And let's say if this is our rise and this is our run, then now for part 2 of B, use our answer to part 1 of B to find the angle at which the plane is descending when it is 4 kilometers from touchdown, and give our answer to the nearest degree. Alright, so what does this look like? Okay, so let's get our, what does this look like? This is it's kind of hard to conceptualize, the angle it's descending. What is that? Well, the angle it's descending would be something like this. So at this point here, 4 kilometers from touchdown, oops, yeah, close to 4 kilometers. The angle of descent would be this. This is our theta. And we know that we have to use part B, the first part, to find this. Alright, so what do we know? Well, we have the derivative from the first part, and the derivative is the slope of this line. It's the slope of that line. So the slope of that line, we know that the slope is the rise over the run and the slope the slope 4 kilometers out is minus 0.0288. Alright, so what would the rise and the run be here? Well, the rise would be, say, this, and the run would be, say, this. And if you notice, we actually have a right angle triangle here. And the run is our adjacent, and the rise is our opposite. So this equals the opposite over the adjacent. And we know that the opposite over the adjacent for a right angle triangle is just the tan of our angle. So now we have an expression for theta, the angle that we're looking for. And so tan of theta is equal to minus 0.0288. And now we can just use the tan inverse function on our calculator. Tan inverse of minus 0.0288. This will give us minus 1.65 degrees. All right, just minus 1.65 degrees. And so remember, this is the angle of descent, and so minus 1.6 degrees is just, the angle that we're looking for. So that would be the angle of ascent, because it's always measuring. This quadrant would be that would be kind of the positive angles. So our angle of descent would just be rounded to the nearest degree would just be 2 degrees. So theta is minus 1.65 degrees, which means the angle of descent is 1.65, because the descent kind of negates the negative. It's kind of like multiplying a minus by a minus. So 1.65, or to the nearest degree, 2 degrees. So the angle of descent is 2 degrees. Now on to part C. Show that minus 2.5, 0.075 is the point of inflection of fx. All right, well, what the hell is a point of inflection? Well, a point of inflection just means the second derivative is 0. It's like whenever you hear turning point, you think immediately derivative is 0. Whenever you think point of inflection, immediately second derivative is 0. All right, well, we have the formula for the derivative. F prime of x is 0.0072 x squared plus 0.036 x. Now if we take the second derivative, again using the rule, the derivative of xn is n times xn to the minus 1. F double prime of x will be 0.0072, constant stays there, by 2x plus just 0.036 by 1, or well, just 0.036. So this just gives us 0.0144x plus 0.036. And now it's saying show that that point is a point of inflection. Well, if we plug in, if we check, if we put in minus 2.5 and the second derivative is 0, well then we know it's a point of inflection. So what's f double prime of minus 2.5? This is 0.0144 minus 2.5 plus 0.036. And if we put this into our calculator, we just get 0. So, and to show that this specific point is the point of inflection, it might be helpful to show that that point is on the curve. That might be useful. Now this might actually not even be worth any points, and you might be thinking, well, are they really gonna say, that point isn't actually on the curve? Are they really gonna give that question? They're not, but it never hurts to be extra careful. So, is that indeed on the curve? So what is f of minus 2.5? Because for all we know, this point here, about here, so this point is not 0.72. Now, it does look like it probably is, but just in case. It never hurts to be too careful. Equals 0.0024 by minus 2.5 cubed plus 0.018 by minus 2.5 squared. And this does in fact equal 0.075. So minus 2.5, 0.075 is a point of inflection. And really, you probably don't need that last part once you show that the second derivative is 0 at minus 2.5. It's probably fine, but I would always advise you to just do that extra part. You definitely won't lose marks for doing the extra part. Now, part D of this question is difficult. Alright, so we have if xy is a point on the curve, so xy point on the curve, verify that minus x minus 5 minus y plus 0.15 is also a point on the curve. Alright, so let's try and figure out what this means. So they're giving us that xy is on the curve. xy on the curve. So y equals fx. Because if we remember, the curve is x f of x. Okay, so we want to see is minus x minus 5 minus y plus 0.15, is that on the curve? Well, if it was on the curve, then it would look like this. If minus x minus 5 was on the curve, then minus y plus 0.15 would be f of x, or in this case the x coordinate is minus x minus 5. So what we're trying to see is, does f of minus x minus 5 equal minus y plus 0.15? Alright, so let's just give ourselves some room. Okay, well, what is y? Well, y is f of x, and we know that f of x, actually let's give ourselves a line, f of x is 0.0024x cubed plus 0.018 x squared. All right, so that's what y is. And now what's f of minus x minus 5? So f of minus x minus 5, well, we'll just plug wherever we see x, or the argument, we'll put in minus x minus 5. So 0.0024 minus x minus 5 cubed plus 0.018 minus x minus 5 squared. And now cubing and squaring minus x minus 5, the easiest way to do this is probably to use Pascal's triangle. So the whole 1, 2, 1, 1, 3, 3, 1, and so on and so forth. So that kind of idea. All right, so in this case, it would give us 0, well, actually, I'm going to take out the minus. So there's minus is a common term from minus x minus 5. And since it's cubed, a minus cubed is still a minus. So minus 0.0024, and then I can just work with x plus 5 cubed, which is easy. And then that will give us x cubed plus 15x squared plus 75x plus 125. And now if you're not so comfortable with this kind of multiplication and kind of going straight from this to this, just go out bracket by bracket. Carefully do it bracket by bracket. And then plus 0.018 x squared plus 10x plus 25. Because if you take out a minus and then you square it, you get a plus. Okay, so let's multiply this out. All right, so we get minus 0.0024 x cubed, and then we get minus 0.0024 by 15 by, this gives us 0.036 x squared, and then 75 by that is minus 0.18 x minus 0.0024 0.0024 by 125 is 0.3. And then we get from the 0.018 term, we get 0.018 x squared plus 0.18 x plus 25 by 0.018. 25 by 0.018. And that is 0.45. All right, and now let's put like terms together. Okay, well, we'll notice that, so we just have a single x cubed term, that's minus, we have minus 0.0024 x cubed. And now our two x squared terms are this and this. And if we take those out, then we'll just get minus 0.018 x squared. And then these will cancel. So we'll just leave that. And then minus 0.3 plus 0.45, and that will just give us plus 0.15. All right, so we have that f of minus x minus 5 is minus 0.0024x cubed minus 0.018x squared plus 0.15. And we want to show that this equals this. Well, it's actually really simple, because if we notice, these first two terms are just minus times this. And this is f of x, and f of x is y. So this is just minus y plus 0.15. Okay, and now we have that. F of minus x minus 5 equals minus y plus 0.15. And we also know that, so we know that this is on the curve, because the curve is f of x, and this is f of minus x minus 5. All right, so it's on the curve. Okay, now finally, find the image of minus x minus 5 minus y plus 0.15 under symmetry in the point of inflection. Okay, what the hell does that mean? I want to find the image of minus x minus 5 minus y plus 0.15 under symmetry in the point of inflection. Okay, so what might this look like? Okay, so let's go back up to our graph and clear it up a little bit. Okay, so what would this look like? Okay, so our point of inflection is somewhere around here. That's our point of inflection. Yes. Our point of inflection is minus 2.5, 0.075. Okay, so let's say we have a point on the curve, and we know that this is on the curve. Let's say our point is here. This is minus x minus 5. Well, the symmetry of this would be, let's use green. Be here, and then double again be on the other side through this point. So it would be this point here. That would be the image of it under symmetry in the point of inflection. That's what it would look like. And so what is that point? So this point of inflection would be, all right, so this goes down here, and then across here, and then it goes down the same amount, and then across the same amount. So that's what its image is under the point of inflection. So if we can calculate this thing, let's call this A and B, then we can translate our point here over to here. All right, so let's try to do that. So our point is minus x minus 5 minus y plus 0.15, and we're translating it under symmetry in the point minus 2.5 and then 0.075. Okay, so what is this distance A? Well, A is the difference in the y coordinates. Alright, so minus y plus 0.15. This is the y coordinate. And then the y coordinate of our point of inflection is 0.075. So minus that 0.075. And this will give us A. So A is minus y minus plus 0.075. So now if we want to find, so this is A. So now if we want to find the y coordinate of the image under symmetry, then we just minus A again. So if we look at this, we are going down A from the point of inflection. So the point of inflection is 0.075. So if we minus, the y coordinate 0.075 minus A minus y plus 0.075. Well, this just equals y. Okay, interesting. So the y coordinate of the image is y. Alright, so now let's do the x coordinate. Well, what is b? Well, b is the difference between the x coordinates of our point and the point of inflection. So that's just minus x minus 5 and then minus 2.5. So that's just plus 2.5. And that is minus x minus 2.5. Okay, so this equals b. And now, similarly, if we want to find the x coordinate of the image, we have to go over another one of these. So we get minus 2.5 and then minus x minus 2.5. And this just gives us x. Interesting. So the point of the image is just xy.